Now then, you know your cables and connectors for the CompTIA Storage Plus exam, as well as for doing your day-to-day job as a storage admin, so don't switch off here. The predominant form of cabling in IP storage, and for that matter just about all IP networking, is copper cabling. And yeah, you're right, we've been using copper cables since the early 1800s. Kinda makes the 50-year-old disk drive look young and sprightly, yeah? However, copper is an excellent conductor of electricity, and it's really good and really cheap at delivering data as an electrical signal over the kind of short distances that we require in the data center, and these distances are usually less than 100 meters. The most common form of copper cabling in the networking world is the UTP cable. UTP is an acronym for Unshielded Twisted Pair, and as the name tells us, unshielded twisted pair or UTP cables consist of pairs of copper wire that are twisted around each other along the length of the cable. Now this twisting is important because it helps with signal efficiency by cancelling out electromagnetic interference and crosstalk. This is where the signal transmitted over one wire interferes with the signal on neighbouring wires, so by twisting them we help to avoid this. And interestingly, this twisting of copper pairs was apparently invented by none other than the legendary Alexander Graham Bell over 100 years ago. And yeah, we still use the technique extensively today. Now, the unshielded nature of the cables keeps costs down, but it does make the cables very easy to tap. And this means if security is a major concern for you, you may want to use shielded twisted pair cables, sometimes called screened twisted pairs. Or maybe you might want to use something like fibre that's a bit more difficult to tap, though this is rarely a major concern within the confines of a walled data centre. So in comparison to fibre optic cables, which transmit data as light, copper UTP cables transmit data as electrical signals. Most UTP cabling used for networking, and therefore IP storage, is terminated with a male RJ45 jack. We show what this looks like on the slide. Now then, technically speaking, the male connector, or the end of a typical Ethernet cable, isn't really an RJ45 jack, it's an 8P 8C connector. But just about everybody uses the term RJ45. In fact, it's so widespread and common that it really makes the term correct. So you're fine to call it an RJ45 jack, and you'll never hear anyone call it an 8P 8C connector. Everyone calls them RJ45, including the Storage Networking Industry Association. So that's what you'll need to know for the CompTIA Storage Plus exam. So now that we know what each end of a UTP cable looks like, as well as how the wires are unshielded and twisted inside of the cable, let's look at the different classifications of UTP cables, known technically as categories. The categories of cables that you'll most likely need to know are Category 5, Category 5E, where the E stands for Enhanced, Category 6, Category 6A, sometimes called Augmented Category 6, and Category 7. And because category is such a mouthful, we almost always shorten it to CAT. So we end up with Cat 5, Cat 5E, Cat 6, Cat 6A, Cat 7. Much easier and way less wear and tear on the old vocal cords. Anyway, inside of each of the different categories of cables are 4 twisted pairs of copper wire. And as we said, they're usually terminated at each end with a male RJ45 connector. There's an amount of backward compatibility between the different categories of cables too. So for example, a Cat 6 based cable is backward compatible with Cat 5 cables. And we can also see in the table on the slide, the higher numbers of category cables have superior specifications, so they can transmit data at higher rates and over longer distances. Now then, for all intents and purposes, the different categories of cables look the same, and you'll usually have to look closely at the information printed on the cable jacket to determine the category and the specification of the cable. It's worth pointing out though that Cat 5 is old now, so you won't see any new installations based on Cat 5 cabling. Now Cat 5e is still seen, but most new installations are based on at least Cat6 or maybe Cat6a cabling, especially if 10 gig Ethernet is a requirement. And if you want 40 gig Ethernet over copper UTP, then you want to go with category 7A. Now, one last point on cabling. For most data center use cases, and we say there up to distances of usually less than 100 meters, copper is cheaper than fiber and it's cheaper than coaxial or coax cable. Coax cabling can transmit data over longer distances than UTP, and it suffers less from EMI, electromagnetic interference, but as well as being more expensive than UTP cables, they're also less flexible. They're really actually quite hard to bend, so quite hard to work with, whereas UTP cables are really flexible and really easy to work with. So all in all, for our standard data center use case, UTP copper cabling is the king when it comes to IP storage. Right then, now that we know all about Ethernet over unshielded twisted pair copper cabling, let's take a look at our first type of IP storage,